I'm Anil Kumar, and here in chapter 3.3, Characteristics of Polynomials in Factored Form, let us try to see how to graph a function when given in standard form. Well, we'll explore more about graphing functions standard form in coming chapters, where we are going to learn factoring techniques and polynomial division. Now here the question is, sketch the possible graph of f of x equals to 12x cubed minus 4x squared minus 27x plus 9. Now to sketch it, we should first factor. So let us try to factor the function, which is 12x cubed minus 4x squared minus 27x plus 9. So I have purposely taken an example which you can reorganize or regroup and factor. So these are the techniques which you already know. We will learn some more when we learn about remainder and factor theorem. So let us rearrange. So we will do 12x cubed minus 27x, and we'll take minus 4x squared plus 9, right? That helps to factoring. 3 is common and x is common, so we can take 3x common. We are left with 4x squared. When you divide this by 3, you get 9 minus 9, right? Let's take minus common here, so you again get 4x squared minus 9. Now 4x squared minus 9 is common, 4x squared minus 9, and we get 3x minus 1. This is difference of squares, so you could write this as 2x plus 3 times 2x minus 3, and you have 3x minus 1. So that is a polynomial in factored form. Now with what you have learned how to sketch, let us sketch it. So what you know from here is you have 3 zeros, right? So zeros are at 2x plus 3 is 0 when? 2x plus 3 is 0 when x is equals to minus 3 over 2. So this 0 is at minus 3 over 2, that is minus 1.5. This 0 is at 3 over 2. So let me write this time 1.5. 3 over 2 is 1.5. 3x minus 1 will be 0 at x equals to 1 over 3, and all the 3 zeros are linear zeros, correct? So we know zeros. Let us try to sketch it now. So we have like this, right? Let's go through our steps as we did earlier. So the steps are starting with your leading term. So leading term, what do we have? Degree is odd. So let's write down the steps. So first we have to write down the degree, and then leading coefficient, right? Then comes the zeros, and then we have to get our y-intercept, right? That should give us perfect graph. So degrees, you know, 3, okay? Leading coefficient is positive 12, so positive is more important. Y-intercept is, when you place this as 0, you get 9, right? And zeros, these are our zeros, all with multiplicity of 1. So no need to write 1, it is understood. That means they are all linear zeros. So let's plot these zeros first. Minus 1.5. Okay, let us say this is minus 1.5. Plus 1.5, let us say this is plus 1.5. And this is 1 over 3, which is 0.333, right? So that is very close to 0. Let me write here. Okay. So we have 3 zeros, all of them linear. Let's start with degree. 3 means odd degree function, right? So we have odd degree, okay. Leading coefficient, positive. Positive means right side up, so we'll say right side is up. Odd means opposite ends, so we'll say opposite ends. Do you see that? And then we have linear zeros, means the line will just cross here, it will cross here, and it is going to cross here. Connecting these points, we get the polynomial, right? So let's connect Do you see that? We have to connect these two, right? So let's connect. Let's not bother about y-intercept now. Let's connect. So once you connect, this is how you connect, right? And then you do this, right? What is the y-intercept? Where the graph crosses y-axis. Mark that point as 9. Do you see that part? This way, if you do, you really get a smooth graph. I'm purposely showing it with different things so that you can appreciate how zeros should be marked and how they really help to sketch a neat graph for a polynomial. Avoid any cusp corner or discontinuities, right? So these are not discontinuities for me, okay? They are connected points, right? Very much. I hope you understand and appreciate it. Let's do some examples and test and review the mid-chapter of polynomials, okay? And then we'll move on to the next chapter. Thank you and all the best.